So the next phase of the build is the receive mixer and ladder filter. And the receive mixer is another one of these SA602 mixer chips. And then we also have the ladder filter here, which consists of four 4.915 megahertz crystals and some associated capacitors. So I'll just zoom in on the actual circuitry that is present here and just sort of walk through an example of that. So let's take a signal at the bottom of the 20 meter band, let's say 14.000 megahertz. That'll be presented through here to pin 1 of the RX mixer. And then that signal gets mixed, if we're selecting that particular frequency. That signal will get mixed from an 18.915 megahertz signal from the PMO that we built in the last step. So this is the path from the PMO, and that gets presented at pin 6 of the RX mixer. And pin 6 and 7 are the two oscillator inputs. And those two signals get mixed together, producing a variety of signals at pin 5 here. So it'll be the same thing, PMO minus the signal, PMO plus the signal, and so on and so forth. So what we're after is 18.915 minus 14 megahertz to give us this 4.915 megahertz signal. And that's selected by running the mixed products through this crystal ladder filter here. So again, the crystal ladder filter consists of 4 of these 4.915 crystals. Now, typically you have to go through a matching process with these crystals. You want them as close as possible in resonant frequency. And I've already done that. I mean, I don't have any sophisticated equipment, but I do have that crystal tester which produces an output. So I had a collection of around 20 crystals, and I picked the 4 closest ones out of that. So you can see after it passes through this ladder filter, the next stage is this IF amplifier. And this IF amplifier, that's the section that we built in the very first video. So that's the next phase of the circuitry. Just to complete this, we've got a couple of transistors here. This is the transmit line here. So this is at 8 volts when the receiver is transmitting. You can see these two transistors just turn on when it's at 8 volts, and they pull the signal here and the signal here to ground, just so we don't get any transmit signal coming back through the receive path. Now, testing the receive mixer is fairly easy. I do have a signal generator that I'll be using here, and I'll just sort of pan up to that. It's the one on the top there. The one on the bottom's one I picked up at a Hamfest last week, and I'm just playing around with that. But basically, what I'll do is I'll set the signal generator to, let's say, 14.020. Reduce the peak-to-peak output of the signal generator. I shouldn't have to have a very large signal here. And then I should be able to receive that, and that should come in as a very strong signal in the receiver, if everything is working, of course. So we'll see that. Again, like I said in the last video, I'm a bit concerned about the level of the output from the PMO. So we'll see if that affects the receive mixer or not, and if it does affect it, well, we might have to do some troubleshooting there. So I'm going to build that up, and then we'll be back shortly with the testing phase. So the receive mixer and crystal ladder circuitry is complete. That's built up, and just to walk you through the various components, here's the SA602 chip here. Here's the crystal ladder filter, the 4.915 megahertz crystals. Here's the capacitors associated with the crystal ladder filter. And then there's an inductor just after the output pin 5 of the SA602, so that's where the mixed products go. And then there is another inductor on the input to the IF amplifier. So that's all the circuitry is ready to go. I have actually tested this, so it is indeed working, but just to give you a quick demo of it working. As I mentioned, I have my my signal generator set to 14.039.5 megahertz, and that's actually on the lowest setting possible. So we should get a good signal into the receiver itself. And so let me plug that in. I've already got the receiver connected to the loudspeaker, so you can hear that signal there. Now you can see here I've got a little antenna just on pin 1, just consisting of a wire. You can hear the tone in the background there, and it'll get louder as I hold the wire. It's obviously using me as a part of the antenna. And to prove that's actually the signal, let me alter the frequency that the signal generator is outputting. So I'll just go up, and you can see that the tone of that the receiver's hearing changes. So that proves that the receive mixer is all in good, and that it has kind of sufficient gain to hear that signal. As I said, it's a very low signal coming out of my signal generator. Obviously the real test is to get it on the air, but I've got a bit of circuitry left to do to get it on the air, and just to show you kind of what's to come. If we look down, I do have to put this circuitry in here. This allows sort of like a pre-selection to the input of to pin 1 of the SA602, and then kind of following this back, there's another inductor here, and then that goes through to a separate section of the circuit that has the low-pass filter. Now, the low-pass filter is primarily for the transmit side of things, so I don't necessarily need that low-pass filter in to hook an antenna up. So what I'm going to do in the next series is build this up, and then I'll be able to see if we can receive some real signals. I usually go on the 20 meter band to 14.074, which is where all the FT8 is. It's an easy signal to receive, so it's kind of like a nice marker to see if you're actually getting anything. So anyway, I'm going to build up this section and this section, and then once I've done that, I'll get back to you. Well, as you can see, the receiver is actually on the air, and someone's calling CQ there, so that's good. I still haven't completed the circuit entirely. As I said, what I was going to do is just build up these pre-selectors here, and then effectively I've got this connected straight to the antenna, so you can see that little short wire there. Let me just move the radio a little bit so you can see it. So this wire here is coming straight from here, straight to the input of the antenna. So one of the things that I noticed on the circuit is there's these two additional capacitors. So here's the trim caps, and they're both 50 picofarads. And then there's these two additional caps here that you use to create the correct capacitance in the pre-selector. And the documentation doesn't actually tell you what those capacitor values are. So, but there's a way of finding out, and I've got this down here to help us. So basically, each one of these inductors are both 2.9 microhenries. So in order to find out with a 14 megahertz signal, 2.9 microhenries, what's the capacitance that you need, this is the formula they use, and there's plenty of LC resonance calculators online that allow you to input 2 out of the 3, and it'll calculate the third for you. So the frequency is equal to 1 over 2 pi root LC. And so with 14 megahertz, 2.9 microhenries, you end up with 44.6 picofarads, which actually fits the 50 picofarad trimmers here. So I don't need to add any additional capacitance in parallel. On the other bands I do, but one of the interesting things I noticed on the band modules is they call out these two capacitors, but there's no place to actually solder them in. So that would be something that I'd have to figure out on the other band modules. So so we're on the air, and well, we're listening anyway. We're not actually on the air, and everything appears to be functioning as is. Like I said, I'll include a link below to the LC calculator. And let me just tune around a bit and find some other points of interest. One of the easiest ones to spot is the FT8 section. That's just up here, I think. I'm hoping you can hear that on there. I don't think that's FT8 actually. So let me just keep going. There's FT8 there. So another confirmation that the receiver's actually receiving. So that's fun. The receiver is now all built, and the next section. Let me just turn that down a little bit so you can hear me. The next thing that I'm going to build up is to start to build the transmit part of this. So I'll describe that in a follow-up video. So that's all for the moment. Hopefully get the transmit section out in the next few days or so. That's all for the moment.